Hey everyone, welcome to today's live stream on using Apache Spark in Microsoft Fabric. I'm super excited to be here. My name is Shabnam Watson. I'm a Microsoft Data Platform MVP and independent consultant. Today I am joined by Matthias Falland, who is on this side. Matthias, let's do a high five.
Hi, Shabnam. Hey,
There we
nice to
go.
meet you.
All right,
Great.
introduce yourself, please.
Yeah, I'm Matthias Falland. I'm living in Switzerland. I'm the CTO at Corporate Software. We're building great data products here. And I'm also a Microsoft MVP, and I'm really, really enjoying to be here.
All right, great. So I also want to give a shout out to our wonderful moderators that are in the chat right now. We have two fantastic Microsoft Data Platform MVPs, Kai Sauter and Usama Wahab Khan, who are in the chat. This is a live session. So if you have any questions, feel free to post your questions in the chat and they're going to answer your questions. Matthias and I are not going to see your questions in the chat. If there are some that they cannot answer, and if there's time at the end, they're going to pass them along to us. Okay, so a couple of slides before we get started. This is a part of the Microsoft Learn series on learning Microsoft Fabric. If you want to follow along with the examples that we show later, you can go to this link. The lab and everything that we show, everything that you see here is going to be from that module. If you are planning to take the DP600, which is the newest Microsoft certification for Microsoft Fabric to become an analytics engineer, make sure that you check out the Cloud Skills Challenges. There are discount codes available there that you can take. Currently, there is a 50% discount code that you can take off of the price of the exam. And even if you don't intend to take the exam, these challenges are a good way for you to get started because they have a very guided path for you to take and get yourself familiar with Microsoft Fabric without getting lost in Microsoft Learn. Also, there is an exam cram session coming up for DP600 that's going to take you over the kind of questions, how to do some timekeeping, and give you some tips and ideas for the exam. And then finally, don't forget about the Microsoft Fabric Career Hub. This is a great website for you to go and learn about everything about Fabric. I have actually made this my homepage because on top of it, there are a lot of links to everywhere else that I want to jump to. So for example, from this site, you can jump to the Microsoft Learn section that's dedicated to Microsoft Fabric. So that's what I use it for as well. All right, so this is the second session of the series of Learn Together. Make sure that you attend as many as these as you can, especially if you're planning to take that exam. It's very important that you know everything that's included in all of these modules. And if you already have Power BI in your organization, you can enable Microsoft Fabric on the existing Power BI capacities that you have. If you don't have Power BI at all, you've never worked with it, and you want to get started with Microsoft Fabric, you can go to, we're going to have the link later. So you can go and go to this link, upgrade to Fabric, and this will actually allow you to sign up for 90 days to use Fabric at no charge to you whatsoever, even if you have never used Power BI before. All right, so in this session, we're going to talk about Spark. We're going to talk about how to use Spark to process data, to analyze it, visualize it. We're going to talk about PySpark and Spark SQL. And the code that we show here is going to be common to all of the Spark implementations, even outside of Fabric. But our focus here today is with the Lakehouse in Microsoft Fabric. All right, so what is Spark? Spark is Apache Spark is an open source parallel processing framework that lets you throw data processing jobs at a group of nodes together. That's called a cluster. So every time you work with a Spark, you're working with a cluster. There is a main node that takes your job, and then it will distribute it across all of these other worker nodes. This process of distributing the work is abstracted away from you in most implementations of Microsoft Spark. So for example, in Microsoft Fabric, when you are working with Spark, all you have to do is to create a notebook and run your notebook, and it will get attached to cluster with Spark running, and it will get the data processing job done for you. It supports many languages. It supports Java, Scala, PySpark, and SQL. And in Microsoft Fabric, it is fully managed for you. In Microsoft Fabric, the way you work with Spark is that you create a lakehouse that Matthias is going to show later, and then you attach a notebook to it. And every workspace in Microsoft Fabric comes with a Spark cluster, and the admins for the workspace, they can manage the settings of the cluster under the data engineering and data science section of the workspace settings. They can specify things such as the node family. This is the type of the virtual machines that each node will be running on, so you can control that. And in most cases, memory optimized is the right choice for most scenarios. You can choose the runtime version of Spark, and you can also go into more advanced Spark properties from there. They can also, the administrators can also add libraries. So when you start with a workspace in Microsoft Fabric, most of the commonly used Spark libraries are already loaded. But if there are additional libraries, more specialized libraries that you want to work with, your admin can go into the libraries section and load those extra libraries for you. All right, so we're going to go to Matthias, and Matthias is going to show us how to create a workspace, a lakehouse, and some of the settings that I just talked about.
Yeah, so let's go. Thank you. Well, so we are here on the Fabric homepage. You have on the left side the different sections that you can browse. On the left bottom, you can change the view. So we are currently in the data engineering view, which is fine for us. And we have the workspaces on the left side where we can switch our workspaces, or we can create new workspaces. So let's go there. I have already, for this demonstration, created our workspace, so everything runs smoothly. But for demonstration purposes, I will create a new one. So there's a big button, New Workspace. I can hit it. I give a name to that workspace, my demo workspace. There we go. Of course, you can add a description to that workspace. You can assign that workspace to a data domain if you want to. So if you follow the data mesh concept, this is really nice. Give it a specific image, and you can attach it to a license mode. In our case, as Shabnam pointed out, we have a trial. So I run it on the trial license mode. If you already own a Fabric capacity or a Power BI Premium capacity, you can also select that one to run the workspace on that capacity, and you can switch the license mode of a workspace later if needed. So that's basically all we can apply, and then the workspace is created. The workspace initially is empty, but we have here the new button, which is pretty long, and from time to time something new is even added there. So we have different options. First, usually you create a lakehouse or a warehouse. In our case, a lakehouse is great. Lakehouse is for reading data. In a warehouse scenario, you can also write data. And when we hit Lakehouse, we need to give it a name, demo Lakehouse. There we go, create. And this will create our Lakehouse right on our workspace in the Fabric. And you see we have the files and tables section. Both is empty. We will upload files later, and or I've already uploaded it for demo purposes. And we will create tables. And when we go back to our workspace, we will see that we have our demo lakehouse, and also the semantic model was created, which is basically the Power Query model. and the SQL Analytics endpoint, where I can run SQL queries directly on the Lakehouse, is also automatically generated. You see it in this graphical representation. This is like a child item on the demo Lakehouse. I can also create a notebook. We need to create a notebook to run our Spark code. So I hit notebook, and now I'm not asked for a name. It's a little bit a different experience. I simply get into the notebook view. I just jumped in, and the notebook has a default name called Notebook 1. I can rename it here on the top. So basically, these are the basics for creating a workspace and a Lakehouse and a notebook. And so, well, now back to Shabnam to get some new theory, and then we will demonstrate the theory again in our workspace.
Okay, Matthias, did you also show, can you also show the workspace settings for the Spark settings, how to find them?
Yeah, that's a great point. Thank you for pointing that out. So, well, on my demo workspace, I have the workspace settings here. And we have this data engineering, data science section with the Spark settings. We have the pool, the default pool, it's a starter pool assigned at that side. We can create a new pool if we have different needs for that pool. For example, this one has a sizing from 1 to 10 nodes. It's a node size medium and it's memory optimized. This is a great choice for most of the workloads, but if you have different needs, you can create that. I don't have the library settings in my demonstration fabric here, so I cannot show you that, but you have seen that on the slide. And you have further options with the environment, where you can define this as a default environment. You can select the runtime version. You can select if you want to use high concurrency, which means that multiple notebooks can run at the same Spark application. So the start time for each session is faster, and you have automatic log, which is enabled by default. So metrics, parameters, and so on are automatically logged. Well, these are the workspace settings. So, well, back to the theory.
Okay. So when you want to run Spark in a Microsoft Fabric, you can create a notebook and put your code in there. And the notebooks give you the ability to run Spark, to run your code interactively against a cluster that's attached to workspace. So you use a notebook, it's going to have multiple cells, it can have comments in there, you can add images in there. So it's a very nice environment, the notebook, for you to interact with the data. And also you can add comments in there for your team to also look at and collaborate. So they're a fantastic tool for looking at data and analyzing it. But you can also use a Spark job definition to run the Spark code on a schedule. So you can run a Spark code in the Spark code in a notebooks using either a Spark job definition, so you can schedule them from here. You can also put them in a data flow that we're not going to show today, but just know that that's your other option. So the main data structure that you work with in Spark, it's called a data frame. So think of a data frame as a table in memory. So you load your data in a data frame, and from that point on, you can further analyze it, display it, and transform it if needed. So what you see on this screen is an example of, let's say that you have a CSV file in the Lakehouse, and it has headers. So for example, if you have product ID, name, category, and list price, followed by the actual values. You can load this into a data frame in your notebook by using this code. So we will use the method of read and load, and then you give it the path to the file, the format of the file, and whether or not it has a header. So this will use the first row as the header and load your data in a data frame. In this scenario, Spark is actually inferring the schema. We didn't give it the actual schema, but if you need to specify a schema, you also have that option. So let's assume that you have a file very similar to before, but this time you don't even have any headers. So before you load this into a data frame, what you can do is that you can define schema, but by the code that you see on the screen, this is very simple. You're basically just giving it the column name and the data type. And this time, when you load the file into the data frame, you specify the path, the format, and the schema. And in our case, this time we don't have a header. So this will load the data into the data frame for you. One thing I want to mention is that because we are working in a Microsoft Fabric Lakehouse environment, we can reference this path like you see on the screen. So this files is a relative path that takes us to the files section of the Lakehouse. Every Lakehouse comes with the tables and a file section. So in this case, that's what this is pointing to. Once you have the data in a data frame, you can further apply transformations to it. So for example, you can limit the number of columns. So you can say, I only want product ID and list price columns, and you will assign that to another data frame. So what you see here, the first example is creating a price list data frame from the other data frame that we just loaded. And you can also cascade these methods. So the second example is showing you that you can select a couple of columns followed by, this is where we're going to apply further transformations, which in this scenario is a where clause. So we're limiting now the rows to mountain bikes. There is a huge number of these methods out there. So for the full collection, you can refer to Microsoft Learn or to Spark documentation. But one of the other useful ones to know when you're getting started is the group by, which is very similar to group by in SQL. So essentially, we select a couple of columns and then we group by one of them. And then we apply the aggregate function after the group by. In this case, it's a count. So this is going to count the number of products in each category. All right, so we're going to now go back to Matthias, and he's going to show some of the codes that I showed you in action.
Yeah, so let's have a look at these code snippets. I'm still in my Fabric window. I switched to my demonstration workspace, and you see I have the demo Lakehouse here, and I have my notebook. When we look at the demo Lakehouse, you see that I have already uploaded some files, 3 files, the CSVs, 2019, 2020, 21 CSVs. These are orders. And when we have a look into that CSVs, you can see that there are no column headers in these files. Yeah? So let's go back to our Lakehouse, to our workspace, and get into the notebook. So notebook is loading. And basically, in the notebook, you have cells. Yeah? You have 2 different kinds of cells. So yeah, now we see it. The first one here, as you can see, is written text. Yeah, it's in Markdown format, so it's very simple. If you use a hashtag, you can write a header. If we add a second one here, so there we go. This is a header heading 2, right? So you can format it and you can make it bold and all that stuff. But you have to hit edit to change the cell. Oh, there's something disconnected. Let's hope that it comes back again. We have a different type of cells. The code cells, these are this one. You can edit these cells directly. Yeah? So you can just place the cursor and write or delete or whatever you want to do. You get also help, as you can see. Yeah? And you can convert this cell. So if you, for example, think this is a markdown cell, but you need a code cell, you can simply hit that button and vice versa, convert one cell to the other type. Yeah? The main main benefit is that you can run the cell directly. I have run all the notebook in advance because first of time and second, then we can jump around and everything is there and everything works. But basically, if I hit run cell, the code is executed and the result is displayed just below that cell. So when I create a notebook and write my markdown and write my code and run the notebook, I have three different types in that notebook of content. The first one is text, second one is code, third one is the result of my code. On the left hand, I have the resources in my Lakehouse. So you see again here the orders. I can go there and have all my three CSVs. Yeah. And I have some other folders that we will create by code later. But as I said, I've already executed the code, so you can see it here right now. So let's go a little bit into that code. First, we read the CSVs. In this case, the 2019 CSV with the option header equals true, which is not true in this case, because you can see it on the result. The first row doesn't contain the header, it contains data. Yeah, so now the first data row is basically our header, which is bad. So we need to correct that. That's very simple because we simply need to set the header to false. And I also changed the 2019 to an asterisk, which means that we read in all three CSVs, not only just the 2019 CSV. Well, looks better. We have now all the data, but we have a problem because, well, the column headers are not really helpful. C0, C1, and so on. These are like auto-labeled columns. As Shabnam showed before, if you have this kind of formatted data, you need to provide a structure. And we do that. So we define the different columns, fields, sales order number, sales order line number, order date, customer name, email, item, quantity, unit price, and text with different types. So we have some strings, we have integers, we have date, and we have float 2 times. And then we read again the CSV, and instead of defining the option how to handle the header, we propagate the schema to the data. And now it really looks great. So you see we have all our data and we have the correct assigned columns here: sales order number, sales order line number, order date, and all that stuff. So to display data, we display it with the display function, and we load it in data frames. Data frames is the type of variable that holds the data in Python. We display exactly that with the display command, and we get, in this case, the same that we have got before. Well, so you see data is in place. We have all 3 CSVs in place. We can check that simply by the date. You see this is 2021, and if I would scroll down, I would see that it's 2020 and so on. Yeah. So we now can explore the data in the data frame. Exploring means we get some data and we want to know the data, we want to understand the data, we want to play around a little bit with the data. So what I do first is I say, okay, I want only to see 2 columns, customer name and customer email. Well, this is my table. You see it, customer name, customer email. But I want to get some numbers, an idea, what's this kind of data. So please print me the customer account. Oh, there's an error, which shouldn't happen. Maybe this is related to our backend pool. So we can execute it again. Let me run. So I want to print the customer count and the distinct count, which means that I can see how much customer I have in the table and how much distinct customers I have in the table. And you see now, oh, that's a bit weird.
I think you got to go from the start and start it.
Yeah,
Well,
I
at least we
think so,
know
yeah,
this is a
yeah.
live, right? This is really live. One thing
This
I
is
really
really live.
like, yeah, one
Yeah.
thing I really like, and I wanted to point out, is that even in your first cell before you ran it, the Spark pool had the cluster had started in 9 seconds previously, and this time I think it was around 5 seconds. So
Yes.
the reason that can happen so fast is because Microsoft has these Spark clusters ready to go. And the moment you run the first cell in your notebook, they will get attached to one of these clusters. So that's why this can come back up so quickly.
Yeah, yeah, exactly. So, and well, now our cluster is running perfectly. You see, I have the customer count here, and I have the customer distinct count. So there are more customers in the table than distinct customers, which is what we would expect. And we see the table here. By the way, there was an error because I didn't delete the folders. I will do it later when we are in theory, and then I will rerun the notebook. This doesn't impact us now. We have the customer name and the customer email displayed as we wanted to. So now we can play a little bit more around with the data. So we can select the customer name and email and apply a where clause. A where clause works pretty similar to SQL where clauses. So we say where the data frame cell item equals the row 250 red size 52. So all customers that bought this row 250 red in size 52. Then we can again print the customer's count and the distinct count, and in this case the numbers are the same, so we have unique customers, and we can display the customers that bought this amazing item. We can do even more. We can, for example, get the product sales, which means that we want to get the item and the quantity and group it by item and sum up the quantity. When we display that, you can see for each item here the quantity. It's not ordered by the quantity, but you can get an idea how much items we have sold. And when we move a little bit along, oops, a little bit jumping around. Well, what's happening here? That's a bit crazy. You see, it's not found. Okay. Well, so I need to re-execute the notebook, and as Shabnam pointed out, this is really fast. So thumbs up that this runs really fast. And then we can explore the data a little bit more. And somebody is playing around with that notebook, which cannot be a little bit weird. So let's see. We already got our data back, and let's move on. Explore data in the data frame. You see everything at there. There's a sum we just have seen. And now we can go a little bit deeper and say, okay, we want to see the yearly sales. So we select the order date, but we extract the year out from the order date and naming the column year, which makes absolutely sense, and group it by year and get then the count. So what the result is, we have the year 2019, 2020, 21, and we have the count of all sales in that year. So that's pretty amazing. We can now start to modify a little bit the view. So for example, not only just create a year column, but also a month column. So we extract the year from the order date, and we extract the month from the order date. Let me scroll a little bit there. You see it from order date month. In the column month, we even split the name field to first and last name. So customer name contains first and last name, and we split it by space. Split column by space. Here you see the space. And then we filter and reorder the columns. Reorder the columns means we write it in the order we want to see them. And now we display the data frame, but we limit it to the first 5 items. So you see first 5 items: sales order number, sales order line number, order date, year, month, first name, last name, email, item, quantity, unit price, and tax. All there. Yeah. Well, this is basically one way to explore your data. You have much more capabilities, of course, with Python. But I think we've got an idea what you can do and how you can transform your data and play around with it and get an understanding of the data you need to work with. So, well, thanks for that, and back to Shabnam with some exciting theory.
Okay. Well, thank you for showing us all that good stuff. So by the way, if anybody's planning to take DP 600, again, it's super important that you learn everything that's in this module, including some of the PySpark and Spark SQL syntax, those transformations. These are things that you're expected to know as a Fabrics analytics engineer. So make sure that you pay attention to this module for the PySpark and Spark SQL syntax. So once you have the data in a data frame, what you can do is that you can write it back to the Lakehouse. This is because oftentimes you want to write it down for further downstream processing or for other downstream reporting tools to pick up and analyze it. So you can do that by using the write method after a data frame. So use a write method to save it. You provide the method. In this case, we are saying overwrite. So the mode is overwrite. We want to write over everything and start from scratch. And then you also provide the format. In this case, we are writing as Parquet, which is the standard format when you're dealing with large amounts of data. And then we give it a path. So notice that the path that we are providing here is a relative path. It goes to the files section of the Lakehouse that Matthias was showing you before. Now, when you're writing data, when you're working with large data, one of the things that you can do to optimize further downstream reporting and usage of that data is to leverage partitioning. Partitioning is a performance optimization method that lets you split your data into multiple folders, and downstream products or applications, or they can reference that data and they can only hit the folders that they need. So for example, what you see here is that we are writing this data frame. We are partitioning by the year column in the data frame. We are overwriting everything. The format is data, and we are providing a relative path. So this is, again, a relative path. It goes to the file section of the Lakehouse. You can have a fully qualified path here, but in this case, we are actually writing to the Lakehouse under the file section. And what you see in the picture is that this will create a folder called data. And underneath it, you're going to have these subfolders with the name of the column that you partitioned with, in this case, year, and the value. So it's going to look for distinct values from that column, and it's going to partition by that. And once you have the data in the so now you have the data in the format you wanted. Now you can analyze it with a SQL once you write it to the Spark metadata store. So let's see how that works. So you can create objects in Spark Catalog. What that means is that they will show up as tables and views in your Lakehouse, and that will enable those users who prefer to use SQL to analyze the data to do so. You can use a data frame to write the data. So we are still working with a data frame. When you have a data frame, you can create a temporary view from it. So the first piece of code that you see here, what it's showing is that we are taking the data frame and we are creating a temporary view called product view. This will show under the views in the Lakehouse, but this is going to be, this does not show under the views in the Lakehouse. This is only live during your notebook session. So once you close your notebook, this is gone. It's just a temporary, it's gone. The next one is what will actually persist there. So you can write it in as a table, and that will show under the table section of the Lakehouse. So far in the demo, Matthias has been focusing on the file section, but you're going to see this, that when you write a data frame and you say save as table, it goes into the table section. And also the format is Delta. Now you can also write a table to an external path, which is the last example that you see in this screen. The difference is that this is called an external table. So when you write a data frame to the table section of the Spark, of a Lakehouse, you are creating what's called a managed table. It means that Spark has the definition and the actual data is also in the Lakehouse, in your workspace. But when you create an external table, it's only the definition of it that is in the catalog, and the actual data is sitting somewhere else. One slight difference that you need to be aware of is that if you delete a managed table, the data will be deleted as well. But if you delete an external table, the data, the underlying data, does not get deleted. So each one of these have different use cases that you can use together to complete a data processing and transformation job. So once your data is in the Spark catalog in the form of the tables, the nice thing is that now you can use the Spark SQL to analyze it. You can do that in the notebooks by two different methods. You can either use the PySpark. So the first example that you see on the screen, this is PySpark, what we call the Spark SQL API to pass a SQL statement to it, and then we will get the results. The other way you can do this is that you can change the language in your notebook, either for the entire notebook or just for that cell that you're working with, to Spark SQL. And now you can actually put SQL in there without having to pass it through the SQL API. So you can notice that this one at the bottom is a lot easier to read. Now this %% SQL, this is called a magic command. And this will let you change the language of one individual cell. So if your entire notebook is PySpark, but in a few of the cells you want to use Spark SQL, you can do this, and vice versa. So I think we are going to go back to Matthias now to continue with the demo. Matthias, back to you.
Yeah, so let's continue. We will jump in, use Spark to transform data files. Yeah. So may you remember we stopped with this fantastic transformation. We created year and month columns, first and last name, and reordered the columns and then displayed the first 5. This is the code. And this is a result, right? So now we can take this data frame and write it to a file. It's a Parquet format. And I already executed this cell. And when I refresh the files section, you will see that I have the transformed data, the transformed data folder. And within there is an orders folder. And when I click on that and expand it, you see that there are 3 Parquet files created out of my data. So this means write data as Parquet, overwrite in this case is not relevant because the file didn't exist before. And we have a success message print, data is saved successfully, transformed. So this is our transformed data. Basically the idea, what we have done in this notebook is we have loaded the data, explored the data, transformed the data and stored it to a different location. So this is a little bit like the medallion structure, right? You get some data in and you elevate the data to the next level, a silver or so, and then you store it somewhere. So just to prove that everything went fine, we can read exactly that data that we have just saved and display it. And this is how it looks like. And surprisingly, it looks exactly as the data that we have displayed before, because this is what we have written into the file. Now you can decide to just not write the orders in the Parquet format, but to store it in subfolders. This is called partitioning. And I have executed that already. And as you can see by the code, I partitioned by year and month, also with the mode override, in the subfolder partition data in the files section of our Lakehouse. So let's have a look how this looks. You see there is a folder year equals 2019, 2020, and 21. And below of that, we have folders for each month because I partitioned by year and month. So 10, 11, 12, and so on. So why? Why should we do that? So first of all, you have some structure in the files. We can get, by the way, a view how it looks in the month folder, and you see there's a target file. So first of all, you have some ordering there, which is great. The second thing is we can now read that data, and when we read it, we see the beauty of that stuff, because you can see we read mostly the same way as we have read the transformed data, but now we can say, please pull out the year 2021 data, and months is everything. So this is like a where clause directly in our data load, which means if you select an intelligent pattern for partitioning data, you can query the data on the load directly, and this makes things faster, smaller, and of course more responsive. Yeah? Because you can filter the data directly when you load it in the data frame. When we display the data, not surprisingly, it equals year 2021 and month everything. So we have November here, and scroll a little bit down, but there's a lot of data. It's all November. So yeah, this works, and this is really cool. And now we have basically the same data, in this case, living 3 times in the file section. First in the orders folder, this is our raw data, or bronzy. Then we have the transformed data and the partition data. The content of both folders, in this case, is the same because it's just for demonstration. Well, we use PySpark. PySpark is great for displaying, for transforming all that stuff. But we can also use SQL. SQL is a very well-known language. Maybe some or all of you can write SQL. I can also, so it's great to use it if you just have a command in your head how to write it. Yeah, so we can do that. First of all, we can describe the table. Then you get a meta definition of the table. This looks a little bit weird because I have increased the zoom factor for the demonstration, so you can read it better. It's a little bit bigger, everything, but of course this breaks up the nice table here. If we execute just standard SQL, yeah, select all columns from demo Lakehouse, sales ordered limit 1000, you see this is the result. And as Shabnam already has explained, you can do it with Spark SQL, with the Spark SQL method, and load it just directly in the data frame. This is cool, but even cooler is to use the magic command %SQL, because after that command you can just write on the SQL a little bit as if you would be in the SQL Server Management Studio or the SQL query tool of your choice. And as you all the great standard SQL stuff is here. Yeah? You select the year from order date as order year. The sum from unit price multiplied with quantity plus tax as gross revenue. From sales orders, group by year, order date, order by order year. And you see the query is even a little bit longer than the result, but it's highly aggregated. We have the order year with the gross revenue per year queried by SQL with the magic command. So, well, that's the capabilities that you can do with PySpark and even SQL by embedding SQL, like this one, or by running SQL with the magic command, like here. The result, of course, is the same. And so let's get some exciting new theory from Shabnam.
Okay, thank you for showing that part. By the way, if you looked in the cells that Matthias was showing, you can either use the magic command, or there's a drop down at the right bottom corner of each cell where you can also use that to change the language that you're working with in each cell. All right, so once you have the data in a data frame, you can visualize it using different methods. First of all, there is a built-in method in the notebooks itself. Every time you run a data frame, you display it, you will see the results. And you can also switch to a chart tab where you can see a very simple chart from the data. And there is some flexibility here. There is some boxes that lets you change the format of the chart, what goes in the rows and columns and things like that. But if you want to do further advanced visualizations, you have access to all of the PySpark libraries and some of the other libraries that are open source and available. So for example, one of the common libraries that people use for visualizations is Matplotlib. Seaborn is another one. And with them, you can create some of these really fantastic looking visualizations. So Matthias, back to you to show us some of these wonderful visualizations in the demo.
Yeah, I will do. And as you have pointed out, we have this small drop down here to switch the language, right? This is the one. I just talked about SQL and the magic command. And so let's do some SQL here. Select everything from sales orders. This is our data. We are a little bit used to it right now, I think. And I can also display it as a chart. If you hit here the chart item instead of table, see it here, it's displayed as a chart. And wow, it looks great, but not so useful in this display mode. So we need to adjust it a little bit. We will leave it as a bar chart. Set the key to item. There we go. And the values to quantity. There we go. And the series group is fine. And the aggregation is sum. Let's apply that. Wow, that looks much better.
Much better.
Much more useful. Yeah, I think so. So you see the different items here with the sum of the quantity. You can even save that as image, as JPEG, PNG, or SVG. So if you need it, for example, for PowerPoint or something like that, this is really handy. So this is like the built-in visualization. You can switch back and forth and compare. Yeah? If you have questions to the data, you can go back and see the raw data. So, wow, that's cool. Let's get a little bit more out of it. So we have the SQL query here, year order date, as order year, some unit price quantity. You know that a little bit. This is a very raw table visualization with the order year and gross revenue. So let's display that data in a nice bar view. For that, we can use Matplotlib. Now, Matplotlib is like the standard. It's a little bit more complicated than other libraries. We will have a look at a more simpler one, Seaborn, later. First of all, we need a pandas data frame, not a Spark one. So that's simple. We use the Spark data frame, convert it to pandas, and then we can go ahead. And we define the axis. The x-axis is the order year. And we then, for the value, we need the gross revenue. So we get 29 in 2020, 2021 with a scalar here on x and y axis. Now we can customize the chart. Yeah? So we can say, okay, we need a title. Title makes sense, so everybody knows what's in that chart. Revenue by year. We can label the x and the y axis with year and revenue. We can adjust the color, the line style, the line width, and so on, a little bit alpha, which makes it transparent. So this is our result. Looks much more appealing, I think. And we can do even more. So let's have a look here. See, we have now the revenue. We have a small rotation in here, 2019, 2020, 21, to compare it. This is all capable with Matplotlib, and we can even create more than one chart. So we have a pie chart here together with a bar chart with Matplotlib. You see, this is called subplots. And you have to describe what you want with the titles and the type. Pie chart, as you can see here, bar chart, and then add a title to the whole figure. This is sales data, revenue by year, orders by year. So now you may ask yourself, hey, why? I have really, really great tools like Excel. Why should I do it here? So several reasons. First of all, it's a really handy way to get into your data, to see changes on your data, because you can. Sometimes it's much easier to understand stuff when you visualize it. That's one reason. The second reason is the graphics are created each time the notebook is run. So as Shabnam explained, you can do it also by schedule, which means in the background. So if you need current visualizations, you can just pick it out here and put it to a PowerPoint or a Word document or whatever. And since it is described by code, there is a pretty high consistency. So the charts will always be and look the same. So it's easier to compare. If you make a year-to-year comparison between the charts, then you can do it really nice. Yeah? It's quite different to an Excel, because Excel can be edited by a lot of people. This notebook is code-based. It's a little bit different audience. So I mentioned that Matplotlib is quite complex. Seaborn is a simpler library that you can use. And you see we have essentially 2 lines of code. If you skip the show, we have 1 line of code to create this bar chart. X means order year, Y is gross revenue, data is data frame sales. That's it. Now we have this fantastic bar chart, 2019, 2020, 21. If you compare that to the Matplotlib code, this is really nice to read. We can do more, as you can imagine. So, for example, now we apply a theme with a white grid. If you compare it, we didn't have a grid here. We now have a grid here. So it's easier to compare the bars to each other. We can create a line chart, of course. So this is really, really simple to use and really simple to create different types of charts. It depends on your background. If you're used to Matplotlib, that's great. If you are new to that topic, maybe Seaborn is easier to get into. So, well, this is the visualization part of the demonstration. I hope you enjoyed it. And, well, back to Shabnam.
Thank you so much. By the way, you didn't actually have to install the Seaborn or Matplotlib. All you had to do was to put in their import, because they're pre-installed. So you just had to do that in order for you to be able to use them. By the way, we didn't show this in this module, but you can also embed Power BI report right there in your notebook. So it's really cool. And like Matthias said, these visualizations help you as you are preparing the data, so that you can understand your data better, and you can also use it for exploratory analysis if that's the goal. All right, so we're going to do a little bit of knowledge check to see how much you guys were listening, and hopefully we're going to see most of the most correct answers. So here we go. So if you scan this QR code here, or you can go type in this link that I believe our moderators are also putting in the chat, you can get to this poll and you can participate. So the first question is, you want to use Apache Spark to explore data interactively in Microsoft Fabric. What should you create? A, a Spark job definition, B, a data factory pipeline, C, a notebook. So here the keyword is interactively. So let's see, we're going to give it a couple of seconds to see if we are getting some answers. Okay, I see some answers are coming in.
Yeah.
We're getting a mix of answers. So we're going to run the code interactively, not on a schedule. So that should hint you between choosing between A and C.
Mm-hmm.
And interactively, it means that we're not going to schedule it in any way, right? Okay, so let's see what the answer is. The answer is C. So you use a notebook to write code and explore data interactively. You can schedule a notebook to run as part of a pipeline, or you can schedule it to run with the Spark job definition. Okay, so next question. You need to use Spark to analyze data in a CSV file. What's the simplest way to accomplish this goal? So again, the keyword here is the simplest way. There's many ways, but we're looking for the most easiest way. A, load the file into a data frame. B, import the data into a table in a warehouse. C, convert the data to Parquet format. Okay, I can see some answers are coming in, so let's go ahead and see what the answer is. The answer is load the data into a data frame, like Matthias was showing us. You can also load it into a table in a warehouse, but this is not the simplest way. Again, these are some of the examples of things that you need to pay attention to. If you are taking an exam, you have to pay attention to the clues in the question that will point you to the right answer. All right, awesome. We got some correct answers there. Now, the last question is, which method is used to split the data across folders when saving a data frame? A, split by, B, distribute by, C, partition by. This was in one of the demos that Matthias showed as well. So let's see, we are getting some votes in. All right. Let's see. All right, I'm going to reveal the answer. Awesome. Everybody got this right, so great job. It is the partition by. It's an optimization method so that your reads further on can use less I/O and they'll be more efficient and faster. All right, so that was the last of our questions. Just to summarize what we were talking about how you can use Spark in a Lakehouse in Microsoft Fabric, how you can run code interactively or on a schedule. We showed you some PySpark code, some Spark SQL, and finally some visualization techniques. If you are planning to review what we showed you, make sure you go back to the Learn Live link that's on the screen to finish the exercises on your own. And don't miss the next session coming up in the Learn Live series. It is working with Delta Lake tables in Microsoft Fabric. This is going to be tomorrow, about at the same time that this session started. So make sure you continue with that because they're going to focus on the tables and continue on this session. All right. And this shows us the tomorrow session again. One more slide, and here we go. So again, as a reminder, if you do not have access to Microsoft Fabric at work, you can go to this link and you can sign up. This will give you a development environment. If you don't have access to anything that you can work with, this will give you a development environment, which is actually what Matthias and I were using to do the demos. We have used this exact same method to create our demos for you. So that brings us to the end of this session. Were there any questions that we need to answer? We have a few minutes left. By the way, I want to give a shout out to Matt Clemens. He's been our wonderful producer, keeping us on track. He's been in chat this whole time, helping and posting links. So take a moment to say hello to Matt Clemens. And also, huge thank you to our moderators, Kai and Usama.
Yeah, thank you so much.
That's it, Matthias. We did it. Here, see if you can do the high five.
Yeah, let's do it.
All right,
Great.
awesome. Okay. Okay, it looks like we're getting one question. Matthias, are you going to read it, or do you want me to read it?
So, interesting to know that you can embed Power BI reports in your notebooks. How to do that? By calling a specific library?
Yes, there's a specific library that you can do. I don't have the link handy for you to show you, but it's super easy to do.
Yeah, and not to mention that the whole workspace concept in Fabric is like the evolvement of the Power BI workspaces. So Power BI is really, really tied to the whole Fabric idea. Yeah. So next question is there any course that you can recommend to become a PySpark ninja?
Oh, that's a difficult one. I'm not a PySpark ninja myself. So the beauty of Microsoft Fabric is that people who are very familiar with SQL, they can easily work with Spark SQL. So the amount of PySpark that you need to learn to get started with Microsoft Fabric is not a lot. So really what you see in the Microsoft Learn modules will get you started, and you can gradually build from there. So that's how I would approach it, is just go as the need arises, look up the method and add to my knowledge base. But otherwise, the Microsoft Learn has a lot of PySpark code examples in it too, really. The data science section.
Yes, I would emphasize that on Microsoft Learn. You have a huge amount of resources where you can start and learn and get even deeper into all that stuff. So for Python and PySpark and the whole Fabric thing. Yeah, it's really cool content. So I think we have got even more questions. What are the things to be focused on this module for the exam?
Ooh, everything in this module. The exam, by the way, is not easy. It's difficult. You need to study for it before you go into it. Make sure you at least go over all the modules. By the way, the exam is open book, so you can have Microsoft Learn open on the side in the exam environment. You just need to know how to navigate to it. So make sure you remember how to navigate to, for example, this module. If you get a question that involves syntax that you're not sure, you make sure how you can navigate to it. So pretty much everything that you see in this module, questions about writing a data frame, saving a data frame, the data transformations, you can get questions on any of those topics.
Yeah. Yeah. Oh, we get even more questions. Well, how does directory work in Fabric Notebook? What is the default directory when I download a file without specifying Lakehouse file directory? So, well, the default section is the file section, of course. As we have seen, usually you create subfolders to keep things a little bit, organized, but you don't have to. I think, by the way, the question was upload and not download. So if you upload, the stuff ends up in the file section. Yeah.
Yes, you upload files. One of the methods to get data into a Lakehouse is by using the upload functionality. And when you do that, it will bring up that file section that you can upload to. All right, one more question. Let's see. How does... no, that was the last. Is there a difference with Spark Lakehouse and Fabric versus Synapse versus ADF? So The one big difference, maybe not a difference, but a performance optimization that I personally love every single day I start a Fabric notebook is that the pools start much faster. So currently, if you work with Azure Synapse Analytics, to get the notebook started, you have to wait maybe 2 minutes, 3 minutes, maybe 4 minutes sometimes. But when you're working in Fabric, it's oftentimes less than 10 seconds. So that's much more time of your day back to you. So that's one thing I've noticed. Other than that, the version of the Spark, I believe it's the same thing. I believe in even with Azure Synapse Analytics, you can, when you create those pools, you can go to the latest one, right? Matthias, that's been your experience.
Yes. Yeah. We have seen that in the workspace settings where you can select the version. Yes, exactly. Yeah. Well, let's see. Are there even more questions? Is it possible to run Python in notebooks? Is it possible to combine Python with PySpark?
I am not entirely sure about that. Looks like Matthias, you're looking that up to see. Yeah, I'm not sure about that. I think the version of the Python language that you work with the Spark is called PySpark.
Yes.
Maybe that clarifies it.
Yes, exactly. And if we have a look at the language switcher, indeed, we have Scala, Spark SQL, R, and PySpark. So we have to stick with PySpark here.
Yes, and actually on that note, notice that the SQL is also not T-SQL, Spark SQL. So there are some differences there. So for example, you cannot do select top 100 star. You put at the end of it, you have to say select star from, and then at the end of it, you use the limit keyword to do that. So there are some minor differences here and there.
Yeah, exactly. So let's check. Do we have even more questions? Yeah, well, this is a good one, I think. If I pass the beta exam, should I retake it when it is general available?
No. No. If you pass it, then you don't need to retake it. Basically, what happens with the beta is that the beta has more questions than will be in the actual GA exam. And once the exam goes GA, those questions will be finalized. So you will be evaluated on the same set of questions as people will take during the GA. So based on that subset of questions, if you have reached the 700 minimum, you can pass the exam. So some of it depends on during the beta evaluation, which one of the questions stay and which ones will leave. So fingers crossed, we'll all pass.
Yeah, good luck.
Okay, so let me bring back the summary slides. And this is where Matt showed me how to go into the slide, the index of the slides and jump to the summary. So I'm trying to do that. Okay, here we go. All right, so everybody, thank you so much for joining us. Make sure that you go to the Microsoft Career Hub, check all the links that are there, check the rest of the series in this session, rest of the sessions in this series. And this session is recorded, so if you need to rewatch it, you can see the link at the bottom. You can watch it on demand later on. So that's all. Again, thank you everyone for joining us. And hopefully this session helped you. And we'll see you later.
Yeah, enjoy the learning path.
Yeah. All right.